So this flip lecture introduces inferential testing, specifically the sign test. So what is an inferential test? Well, remember, the goal of all psychological research is always ultimately to collect data, analyze the findings. Okay, so we can analyze data in lots of different ways, and there are two main forms of analysis we can do. Our first one being descriptive tests. Now these are ones you've come across before, but we just not called them this. So these try and make sense of data in a way that is, well, descriptive. They describe what we're seeing. So things like graphs, percentages, averages, measures of dispersion, etc. Okay, these tell us about the data. The average score was 7. Okay, the correlation coefficient is positive 0.5. Alright, they just tell us about it. What we're learning about today, what we call the inferential tests. Now this is what allows us, from a set of data, to draw a conclusion. Okay, so if we're certain the result, the data, if we're certain our data is the result of the study, we say it is significant. Okay, so let's say we've seen a change in reaction speed after having a drink versus not having a drink of some kind of new reaction speed increasing soft drink that we're trying to develop. Okay, now if we're certain that this change in reaction speed is due to this IV having the drink, not having the drink, then we're saying it's significant. Okay, we're confident the data has not happened by chance. So people in the condition with the drink have been quicker than people in the condition without the drink. Okay, sometimes you'll see inferential testing called significance testing, because we are testing the significance level, the confidence in our results. So how confident are we? Where do we get this idea of confidence from? So confidence always comes down to our level of significance. So again, it's another phrase that kind of refers to this: how certain are we that our results have not occurred due to chance? And we call this our p-value. The probability our results are due to chance. So the common ones we see in psychology tend to be p equal to or less than 0.05 and p equal to or less than 0.01. Now you can probably figure out what these values mean if you have a bit of knowledge about decimals, percentages, statistics as a whole. Okay, if you're a bit unfamiliar with it, have a quick think. Pause the video. What could these values tell us? Okay, so I'll give you the opportunity to pause. I'm assuming you've started again. So p-values. Well, p equal to or less than 0.05 means the probability that our results are due to chance is equal to or less than 5%. Now, this obviously tells us something else as well. How confident are we our results are not due to chance? Well, 95%. It's always this kind of opposite. We can always turn this information on its head. The other value we looked at, p equal less than 0.01. Okay, the probability our results are due to chance is equal to or less than 1%. This therefore means that we are 99% confident that our data, our results, is not due to chance. Okay. Like I say, this is an inferential testing design test, and it requires this p-value. Okay, it's essentially the amount of rigor, how strict we're being with our data to say how much we trust it. Now in psychology, the lowest p-value you'll see in any piece of research is 0.05. Now that is kind of the minimum we'll accept. A lot of research is higher that you've seen in terms of we're being more and more confident. So p equal to less than 0.01, 0.001, etc., etc. But you'll never have a p-value that is kind of greater than 0.05 numerically. So you'll never have a piece of research that has a confidence level, a significance level of significance that is, say, p equal to less than 0.06. Okay, because that would be not strict enough for psychology to accept. Okay, so like I say, as a rule, we're only accepting results if we can be at least 95% confident in them. So our standardized p-value is p equal to less than 0.05. If in a question or in the exam they are asking you to conduct a sign test, which they can do, and they don't tell you what p-value they're using, then you can assume that they are using the p-value of equal to or less than 0.05. That is how standard it is. Okay, they're expecting you to make that assumption. So the sign test itself is one type of inferential test. There are loads and loads and loads of different types out there, and depending on how far you pursue psychology, you will encounter more and more and more of them throughout time. Okay, if you do any kind of science at kind of a degree level, you'll come across a lot of different types of inferential test, and they're all the same. They all have served the same purpose, and they all look at the same types of data. Okay. Now, a sign test is the simplest one, really. It allows us to quickly see if our results are significant. And we're going to have a little work through one together before we do one in class, and you're going to do one yourselves. So before we can do any kind of testing, we need some hypotheses. Okay. So this idea, let's look at this example. We're saying a researcher is measuring the severity of symptoms of depression on a scale of 1 to 100. 1 in a sense being not very severe symptoms, 100 meaning very severe symptoms. Okay, that's what we're measuring. It's our DV. Now, depressed patients will have the severity of the symptoms measured before having a new form of CBT treatment and after having a new form of CBT treatment. Okay, and previous research suggests that the new treatment should lower the severity of symptoms. So our IV here is before and after treatment, because that's where we're taking our two measurements from, and our DV is this measure of severity of symptoms on a scale. Okay, and we've got some previous evidence to indicate the direction that we should be seeing. So in terms of appropriate alternative and appropriate null hypotheses, this tells us which direction we should be doing. Okay, for our alternative, should it be one-tailed or two-tailed? So because there's previous research that indicates a direction, we should be doing a one-tailed hypothesis. Right, and I've written this one out for you. Participants who have completed the new CBT treatment will score lower on a scale of 1 to 100, measuring the severity of their depressive symptoms compared to the same participants before they have completed the CBT treatment. Sounds a bit wordy, but this is just as detailed as we need to be. And just like when we learned hypothesis writing, we are writing it here in the same way we always have. Okay, we start with one condition of our IV, completed the treatment. We then lead with our DV, what are we measuring? So their score on the scale. Okay, and we finish up with our second condition of our IV, before they have completed the treatment. IV, DV, IV. We always write a null as well. So our null, there will be no difference in the DV, so the score on the scale, between both conditions of our IV. Participants who have completed their treatment, the same participants who have started their treatment. Okay, so before and after. So these are two hypotheses. Make sure you know how to write hypotheses. If you want any kind of practice with them, please let me know. I can give you some examples to work through at home or independently. Okay. So the sign test. Well, to decide whether or not this new treatment is actually effective, we need some key information. Okay. We need what we call a calculated value, which is a value we calculate from the test itself. We need the N value, which is just the number we're looking at. We need to know if a one or two-tailed hypothesis was used, which we already know. We need the p-value, which we can assume, and we need the critical value, which is what we get from a critical table. Okay, but we need to actually carry out a sign test to get this calculated value, so we have to look at the results. So here's a mock-up of the different results. Okay, we've got before treatment their score and after 1 week of treatment their score. So the first column starting at 85, going all the way down to participant number 8, going to 20. Then after 1 week of treatment, we see that obviously these scores have changed. All right. Now, the other columns we've got here that are blank, we're going to be filling these in. So to calculate a sign test, it's always done in the same way. All right. You have your two conditions of your IV, and we have the difference column. Now, it doesn't matter if you do after minus before or before minus after here, as long as you're consistent throughout, because it will always give you the same result at the end. Okay. Now in this example, I'm going to do after minus before, just because to me it made the most sense to do so. Okay. So obviously here I'm going to do 75 minus 85, because that's the row 1, the after column minus the before column. Okay, and that will give me minus 10. Column or row 2, sorry, participant number 2, it'll be their after column 50 minus the before column 70 to give me minus 20. Okay, now I need to do this for every single column so that I have all of these different values here. All right, now this last column right at the end, sign, this is just to help me out, to help me see nice and easily what signs we've got here. So the sign test does refer to this idea of positive or negative. Yeah. So the difference between our two conditions, is it a positive difference or a negative difference? Okay. So what we can see here, we've got 6 negative symbols and 2 positive symbols. Okay. Now that's important. We're going to need to remember that. So our calculated value is the number of the less frequently occurring sign. Okay, that's the language we need to use. So less frequently occurring just means the one which is most infrequent, the one that is least common. Yeah, the one we have the fewest of. So in this case, our calculated value is 2, because there are 2 positive signs and 6 negative signs. So the smaller number here is 2, so that becomes our calculated value. And our n value comes from the number of matched pairs of data. Yeah, this is our participants. The ones we have are before and after condition 4. And this is n equals 8. Okay, so we've got our calculated value, that's 2. We've got our n value, that's 8. So our one-tailed hypothesis is being used, making this a one-tailed test. Okay, and we're assuming the standard p-value, which if you remember is p equal to or less than 0.05. Now this is all the information we need to be able to use this critical value table. Okay. Now a lot of students like to look at this and they look at it and they see all the different numbers and they think, oh my god, that's loads of numbers, I'll never be able to do this. And I guarantee you can. Alright, you're not working anything out here, you're just choosing the right number from this column based on the information we have. Okay, so you can see there it's got significance levels at the top, yeah, based on either a two-tailed or one-tailed test. Right, you've got an n column and you've got the different columns going along for the different significance levels. Okay, so here it is a bit larger. Now we are doing a one-tailed test, which means that in this column where it says significance levels, we're using the bottom row. And our p-value, remember, was 0.05, which means we're looking at this column here. Okay, because it's the one-tailed test and 0.05. Above it, in the other row above, there is a 0.05 as well, but we're not using this one because if you look, that's labelled as being for a two-tailed test. Okay, so we're looking at this row, this column, sorry, and it's 0.05 for a one-tailed test. Now we need to know which row to look at here. This is where we plug in our n value. So n, remember, was 8, which means we need to look along this row, and where these two kind of sections intersect, that's our critical value. Okay, so for a one-tailed test, p-value of 0.05, for an n of 8, our critical value is 1, because that's what number we're left with. So what we know about the sign test is that if the calculated value, if it's the same or less than the critical value, then our results are significant. Yeah, so we can be confident that our results have not occurred due to chance and that they are actually useful for us. So we have to think, are our results significant? Well, no, they're not. So in this circumstance, our calculated value 2 was greater than the critical value. Okay, which means that they aren't significant. Now what we can tell from this, because it's still useful to know really, is that there's actually a greater than 5% probability that the results we saw in that table earlier were due to chance. So it could have been due to things like life events, could have been due to other treatments, could have been due to individual differences, could have just been random chance based on the participants we had and when we took the measurements. Okay, but we can't say that the change in severity of symptoms was due to the treatment. Yeah, this means we reject our alternative hypothesis and accept the null hypothesis. Okay, there will be no difference in the score on a scale of 1 to 100 measuring the severity of depressive symptoms between participants who have completed their CBT treatment and the same participants before they have started their CBT treatment. And that's a sign test done, completed. Okay, so some of you were worried about doing statistics in psychology, but this is as difficult as it gets. Okay, so just one more thing before we go, because sometimes we have a set of data which doesn't change. Right, so we may have here before treatment, after treatment, and it's 75 on both. So there's no difference and there's no sign. Now obviously when we're looking at the sign, we're adding them up, looking at the difference between the different numbers. We either go for the number of positives or the number of negatives. Now here a sign of 0 really would throw a spanner in the works. Okay, so what happens here is we ignore that set of data. okay, and we reduce our n value. So let's imagine that this was included in our data before, so there would have been 9 participants. Well, here we would have just ignored its its difference, its sign, and we would have reduced our n by the number of data sets, so 1, so leaving us with 8. Okay. Also, data may not be numerical in a sense. Right, so the sign test, assigning a sign and looking at that, is essentially a way of ensuring that all data is quantitative. Right, so we've got view at the beginning of the year here and view at the end of the year here in terms of political leanings, and we've got people who are changing their view, people who are staying the same, and people who are changing their view the other way around. Okay, so in terms of working out the sign here, well, it's just this idea: has it changed? Has it stayed the same? Now, if I were to give staying the same positive and changing negative, then we can see here our calculated value would be 2, because that is the less frequently occurring sign. Alright. If I were to decide the other way around though, that actually staying the same I want to be negative and changing to be positive, then again my calculated value is still 2, because I would only have 2 negatives in that example. Alright, so it doesn't matter which way around you're doing it, as long as you are being consistent. Okay, so in A level we'll cover different inferential tests. Okay, so when we use a sign test is when we're looking at the difference between sets of data, so it has to be an experimental method. Okay, so when we're using repeated measures or matched pairs design, because it has to be the same people in both conditions. Alright, and when we have nominal data, so categorical data. Okay, if it's not category data, like I say, this assigning of a sign forces it into categories just for the purpose of the test. Right. So if you're ever asked to justify why should we use our sign test, then you can tell the examiner, you can tell me, that's because we're looking at a difference between 2 sets of data, and the data is related because it uses either a repeated measures or a matched pairs design. Okay, let's say we're going to practice this in class, so make sure you kind of understand how to do it. What you might find helpful, go back through the video and just write kind of a numbered checklist. What are the steps you have to follow to do a sign test? Okay, any questions, like always, just come and speak to me, email me, whatever. Okay, goodbye.